Alright, so for a couple of days I've been working on this PR. Let's see here. Code Hadron. Let me zoom this in. There we go. It's 250. So this thing, 5 days now. A lot of pushes. Kind of growing. Oh, goodness. Look at that line diff. I had no idea that it was getting that big. And it all started with a fix to the garbage collector. But that uncovered a lot of underlying issues. And because the fix specifically was finding out that after running the benchmarks that the garbage collector wasn't collecting any garbage. Only in very corner cases was it actually collecting garbage. So 1 line or 2 line fix, I think it's, you know, 1 or 2 lines of that 5,000 lines is a fix. This one, where we were asserting on gray objects or when we shouldn't be. This one, where we were things that are marked should be pushed back to live. So in the marking, this is owning something. Not only were we marking it as gray, we need to actually take it. And then I think there's literally like 1 more. I think that's it, but yeah, I mean, like a couple of fixes. So of this, you know, line diff of coming up on 6K, the you know, maybe, I don't know, 10 at most is the original bug fix. However, then you go to test the crate. You go to run Rust over here, which I finally got working. You go to test the crate, and it's just a mean, it won't work right now. But yeah, it didn't work. It exposed a lot of bugs, and basically the bugs were of a couple of varieties, but mostly of the variety of, hey, I have been relying on the garbage collector never collecting pointers out from under me while I'm working on Rust stuff, and now we have this like non-deterministic process that's running. And I think I have it turned up pretty aggressively right now because I was like, why isn't the garbage collector collecting garbage? And so I have it doing a lot of, like, it's constantly scavenging for memory, you know, because that's better than we can performance tune it later. But, you know, I like right now that it's uncovering these bugs, but it uncovered a lot of bugs. And it also really brought to a head. So I fixed a couple of those bugs. Then it uncovered a bug which had been, you know, it's a piece of tech debt that's been lingering in Hadron for a long time, which is if we go back to Chrome and walk through the code right now. Here we go. Code. Plain. Oh, I'm not a bot. Benches, but thanks for checking, honestly. Runtime, garbage collector. So here's the garbage collector as it exists in the repository today. And we go down here and we see that there's that it's parked in a thread local storage. That there is a thread local macro right here on line 451 that says, hey, you know, I am basically a global variable, because you kind of, I didn't really want to pass the garbage collector around every single place that you need the garbage collector, because that's a lot of places. I kind of wonder if that was actually the right call. But it does add a fair bit of function call overhead, like that's another register that you're putting an argument into. Granted, it could be the only thing that you need to pass around, not the garbage collector, but anyway, another thought. We'll get there. I'm getting ahead of myself. So right now, though, thread local, we got this static thread local for the garbage collector. We also have one, turns out, for the interpreter. So this became a pattern where if you scroll down to the bottom of the interpreter, you'll see a similar thing. I don't know where I hit it. Let's look for, yeah, very last line. Okay, so here it is again. Thread local. There's an interpreter. We also, unfortunately, got it for the symbol table. Nope. Table. This one isn't as bad, but it's not great either. So there's one. And then we got it also, lastly, for the class library, which is probably the worst of them. But the problem is that you don't have strict control over when thread locals get initialized. You cannot rely on initialization order. It also turns out another bug that the garbage collector uncovered is that when you are deleting an object, when you're in a drop, you cannot access thread local storage. So this thing is not very, it's not great for storing stuff in thread local that has interdependencies on other thread locals. And I think that this is a bug that sort of plagued me for a long time, is that sometimes in the tests I'm making a language, I'm making a garbage collector first, and sometimes I'm not. Or I think I'm always, I don't know, there's some undefined set of situations where the library can come up and it doesn't seem to know about its some of its basic classes, and I'm kind of wondering if they've been garbage collected or like what happened there. I think actually the library not knowing about classes is a weird bug that I have in inventory. But I definitely think that the creation order problem is a real problem. And I've been, like it was tech dead and I was aware of it, but I was thinking, okay, I'll get to it. But then I hit it really hard when the garbage collector started deleting stuff. And so that's why I have been struggling mightily. So I came up with an API. And I designed the API in probably the most baddest way possible, which is that I kind of just built out as stuff as I needed it, and sort of, but it's in this lang file, and I've never actually compiled this thing well enough to get to clipping warnings, but now I got a clipping warning, which is that it's module inception, because the name of the module is lang, and I cannot have a submodule named lang, or at least Clippy says that it's bad practice, and I get it. So it is now the one thing that lives in thread local storage, and you have to intentionally set it in thread local storage. You have to say, look, I'm using this lang. That's a little inspired by Tokyo, which has thread local, not thread local storage, but task local storage, that you set at the start of a task and sort of say, hey, you're doing this task, it needs to know the following things. And I think that's really cool. And so I thought, well, let's do the same thing where you kind of have to be intentional. Like, I'm using this language implementation, and I think lang is actually a really bad name for this. So that's probably the first thing that needs to be redesigned. But I literally looked at thesaurus for, like, we're already using context. I like context a lot. I had thought API is another one. I don't know. I'm probably gonna have to rename this. But the idea is sound, I think, which is that now you have a collection of all the things that used to live in TLS. So you've got your garbage collector, your symbol table, your library, and your interpreter. These are using a class that I had designed, a struct that is basically saying this thing is garbage collected, but it lives in the root. So as long as I have a pointer to it, it's in the root. And it's a ref counted pointer on the garbage collector side. So you can have multiple of these, and it won't consider it it won't consider it as a candidate for collection until all of them are dropped. That's the right way to use super collider objects outside of the context of plane. So there's a problem here that is happening. So I went and I rewrote a bunch of stuff. Said okay, and this is why this change is so massive, is because we have everywhere uses all kinds of crap. Everywhere is making edges, which are the internal reference counted garbage collector thing. All the code has been written to that. If you even go and look at Hadron, where am I? Not here. The Hadron binary, it's main.rs, I think. Yeah, if you look at Hadron, all of this stuff was using edges, like file, and I think right now if you try to run Hadron, you get an error when you because it's still making edges. Like if you look at the file interpreter, I think interpreter. I tried to do better by putting it inside of this. Oh, I'm not even matching it. Yeah, this is gonna crash. So let's talk about why it crashes. So we've got this domain. File reader, read file, file path, and wrapper else. And then if it doesn't work, we do a general error and we kick out of the program. If it does work, though, we have this edge domain. That's the type, edge domain. Now, edge is, if you go and you look at the comments to edge, any object that Hadron Rust code would like to explicitly bound the lifetime of should be contained in an SC pointer. Internal references, that is, transitive references to other objects from an SC, can be represented by edge directly. So I'm breaking my own comment rule. Oh, wow. Yeah, wow. And the pin I deprecated, so this comment is deprecated. Anyway, boom. Oh, so this is in SC. This isn't the comment for SC. So, and it's not. It is now appropriate for use in a GC. So anyway, I should put in a comment. Well, the thing is that I want to make edge. Let's see, edge drop deref edge. This needs to be pub crate only. This is only crate. Yeah, this thing is should only ever live in the crate. Like, you should never be able to make an edge, and that's the problem here, is that we are making an edge. And this should be an SC. So what happens is there is a chance between reading this file and that this edge will be garbage collected, because nobody else has a reference to it. Like there's no part of the language, you have not yet brought it into the language. And why is this thing even delaying interpret? So now you're bringing it into the language, but it's still, I don't think it's ever actually connected to anything for a little while. In fact, ever. Yeah, no. There might be some compiled code, but like all that stuff is, so all this stuff is getting garbage collected right out from under us during interpretation. So the domain, which contains, the compiled thing, is getting compiled out for us. So so file reader needs to start returning an SC, but we just broke a bunch of code because now we don't allow edges outside of the thing. So the first thing to improve safety here, I think, is make edge completely private. The second is that I have been exposing some stuff but not a lot of things. I just feel like I'm having to stamp out a ton of fires, and it sucks. But I think that was a good first step, and I bet you now, if I try to test all, that there's going to be tons of build breakage, and that's great. Great public edge. Yep. Pub crate, use edge, pub crate, crate, use sc edge. Yeah. Okay. Boom. This is the errors unit test. Yeah. You need to use sc. Okay. Then that's going to break a bunch of generated code, but let's keep grinding away. Love it. There's actually less breakage than I had anticipated. Okay. Nil errors. Yeah. What is the problem? Oh, you need another print, I guess? No? Oh, goes the other way around. I don't like that. That's probably the wrong order. Problem? Oh, Jesus. It wants the garbage collector specifically. Okay. Are you with me now? Yeah, okay, cool. Yeah, I think that's actually the right way. It's breaking up the transitive circular sort of dependency. That's really tightening the loop, honestly. But okay, build. Okay. We're going to do one round of import cleanup, I feel like. No. You have Lang, right? Nope. You need Lang. Formatter has it, I think, already. Needs ref cell. You know what's crazy? 2 tabs at the same time. Yeah, you're going to need both. Yep. Because what you're going to do is you're going to say, hey, Lang. Domain equal Lang. New domain. String. Is the string? Bytes. Bytes. Why do you want a string? Oh, name. Name. Cool. Cool, actually. You have the name of this thing. Yeah. Path dot as to stir string lossy dot to string bytes. Yeah. There you have it. Okay. You're fine. This is better anyway, because that exposes a lot of internal implementation deals. Yeah, which is just kind of dumb. New domain. New. Oh, you're inside the lang. Why are you doing this? The domain equal string new eval buff as bytes to vec. Boom. Oh. Let claim format take care of that. Okay. Nope. Lang interpret needs to change. Why do you want a okay. It is private, yeah. I don't know why you did that. That is terrible. Okay. Oh, Lang. Okay. Yeah. We have to change the Explorer. Yeah, that one. You are going to take an SC domain. Cool. Okay. You take an SC domain too. Yeah. That's fine. this should be an SE. No, that's an internal edge. That's okay. What's the problem? I'm just hitting every branch on the way down on this tree. And then I climb up again, and I'm like, well, maybe a slightly different way, and then I'm, Oh, you're killing me. You are killing me. Yeah, I don't think SC laying is serving us outside of this doesn't work, and this doesn't work. This macro does not work. Of the crate. So macro export, I think, is you can't use it anymore outside the crate. You're inside of the crate. Okay, so that means let's look up macro export. I'm a little curious about that. Rust macro export. Okay, we're nice and zoomed. Yeah. Scoping. Okay. So yeah, this is right. Will not compile outside the crate. Macro will not compile. Does not work. It's not correct. Private structures and will not compile outside the crate. Okay. Fixed it with a comment. Oh, I'm back to post over. So we'll try building again and see where we get. Yeah, who's using it? Fuzz tests. Fuzz tests. Okay. Build fuzz. Who's using SC lane? One of two uses. I'm using edge, which is terrible. This should be lane. Lane new. Lane. Dot. New domain. We're just going to use the thing we just wrote. Or the thing we just fixed. New domain. I think it's toString.as bytes. Oh. Sparker's the other one that sucks. Okay. Yeah. New null post, which we're already doing. Dot. As bytes dot to vec. Okay. So it's just lex literal dot as bytes dot to vec. Cool. Let domain equal. Okay. We need to do the same down here in Sparkler. Lane. Pull you out. Lane, new domain. Dot as bytes dot to vec. How do you like me now? You're going to need to change sparkler.rs2 to use a... okay, cool. Cool. Oh, it gets a name. Okay. We forgot that both in yeah. Okay. Here in build fuzz. bytes. You have a pretty common way to do this, which is just where you say eval file literal. This. So we need a name for all of our inputs. They have to have a name, and I like to do the name of the file because it's right here, fuzz file path, and we can call this fuzz file literal. And then this needs to be toString. String. We'll do a similar sort of trick down here in Sparkler. Path. Sparkler file literal. File literal new Sparkler file path. Path. Here, file, indent that. We are not animals. Where are we now? Ooh. Hmm. Hmm. Where else is this breaking? I just want to see the whole undoctored list of errors. Just build the package for now. Okay. So yeah, Cargo's laying his building. It's just okay. No. Ah. Okay. Let's. Okay. Cool. Hi. Is there a way to no warnings, suppress warnings? Oh God, there's no. There we are. Okay. Edge is private. Okay. So for these, my inclination is to literally just expose this is terrible. That should change. Um, okay. Okay. I don't think that source file should even be a public type. Like, domain should sort of be like, if you need access to, okay, so there's two APIs. Hadron has two APIs right now, or it has two, its API is doing two things. One is allowing you to run the interpreter. So you can, add class files. Yeah. Um, yeah. I think like this is starting to make sense to work on some at least preliminary documentation. Docs, Hadron, API. The catalog is such a bad call. Adding stuff is always such a pain in the butt. New markdown file. I'm just going to copy this front matter from here. Just go, yeah. Put it here. What? Okay. Hadron API. Serves Hadron API, compiler API, and interpreter API. So Hadron's API is broken into functional groups, compiler API, and interpreter API. Some general rules. If we expose garbage collector types, they must always be with be via the SC type, so that to avoid the vagaries of garbage collection. Compiler API, interpreter API. There's a file management API needed. This is needed. But right now we're just limiting people to SC domain, and adding functionality inside that for other needed things. source file within compiler API, lexing, parsing, diagnostics, interpreter API. Important to understand. Once LSP support starts coming in, which should be very soon in 2025, even though it's already mid-September of 2025, which is like, oh my god. Okay. Compile class library. Compile class library. Interpret code. That's it. That's it. So those are the pieces of the API. Okay. All right. So, knowing all that, I don't know why I have to sync Hadron project again, but I think that a little bit more cleanup is due here, but I still think we're on the right track. That we are. That we are going to focus on adding crafted domain for now to expose the underlying okay. I hate it when they do that to me. Struct is what I want. So you want locations, which are what? It's a vec location. It's a vec of location. Which is, you already have it. Source file location. happen. Yeah, because it's creating a GC ref. The bar is creating a GC ref that dies. Huh. So what we're going to need to do is it's going to return the location. Get locations. Create copy. Creates a copy. Clone. Clone. Now what we're going to have to do locations domain bar dot get locations. Then we just get to go locations. It's still really crazy long. Yep, still really crazy long. There we go. Find get input name and self returns a string dot borrow dot input name clone. We have it. Get input name. This is all improvements. Oh, you're fixing the wrong thing. You need to fix the that's good. There it is. Who's in fuzz, I think? Or where was that? That's in errors. No, you're in the top one. Sort of an opaque type. No, it's not. That's okay. Get input name. No, you're right. That needs to be in a width. Really funny. Any dereference. Domain.borrow dot get input name. I think, have I already get source file or get? This is terrible. This is really terrible exposing implementation details like this. It's hard hard when you try to like retrofit an API on top of something to meet the existing use cases on the back end of a PR that's supposed to be mostly unrelated. But you know, hey. Oh my god. Add to cache. So this is the source cache. Yeah. Really what I want to do is I was gonna no, you're inside of a lane width, so what else do we have here? Are these your only objections? So what happens if we 387 warnings cargo test minus p length. Oh, yeah. I'm gonna kill that code. Bye-bye. Excellent. Okay. Excelente. Okay. So the error formatter is really, we are building everything. The error formatter is the only thing that wants the bytes from the files. So I really think that and it's these two lines. Already have domain borrow. I think we just add get input bytes, put fun, input bytes, source bytes, input source bytes, fun get input bytes, and self returns a deck UA. The source file dot borrow dot bytes dot clone. Yeah. There you go, baby. That has to be done within a width, but lane domain dot borrow. No. You also need access to a look at interpreter. I deleted these and moved them to Lang. Just thought. I think we are moving in a direction, so I'm just gonna more churning and burning. Okay. If I move this crap to Lang. Oh no, I hate that. Who calls it? Who calls get source file? Single use. Okay. I see. This is the laziest thing. It's incredibly stupid, but okay. There. I'll go back to doing it, clean this up. This one. Don't need it. Bam. This borrow sources at boom. SC wrap. Does this work? No. I thought there was like a take. There's no take. At the bottom. That's an edge. Clone. New in, new empty in. Oh god. You cannot make an SC from there. You have to call the interpreter. You have to call Lang. That's okay. It was okay. It was okay. There should also be a something like rep from. Great. Wrap in, inner. This is terrible, by the way. The order of this is everywhere else Lang. Lang is Lang is garbage collector. If edge dot is sum. Edge. Just call this edge. Is sum. Oh my god, why are you so mad? What are you so mad about? What are you so mad about? Item expected. Oh, you have to say it's a function. Sum. Mute. Dot add root. Edge. Mute edge. Mute. Oh. Let's see. Edge DC. Cool. Okay. Wrap in. So now we've got that. So now we can go over to lang and we can say, what was this thing called? Get sources, incompatible types. No, this returns an edge. Returns an edge. You don't need to know about. Okay, yeah. You can leave that unmolested. I don't think that we need SC anymore. We'll kill it. We'll go back to lang and we'll add a method. Just get sources. What does this one return? Get source file. Yikes. Okay, it's going to return a lang, rc ref cell lang, and it gets a path and stir, and return an option, sc source file. Boom. And then we go wrap TLS lang let equal interpreter and then it's something like borrow source file path map. To sc wrap in. Lang.borrow edge lang.borrow garbage collector. now returns an option SC file. So let's try building again, and that should bring us back to the error, which is this, which is bad. Lang clone, lang, target source file, lang. I don't like it. Oh, you haven't exported it. Test all. Okay. Try a couple different use cases for Hadron. And this is good though. This is good. Yeah. Okay. Cargo run minus L bench classes minus I bench Hadron. Oof. Why is that type completion taking so long? Scripts eval bench all. Crashes unwrap on a let's see the backtrace. Curious. You can get a hint. Boop boop doop boo. File interpreter. File lang.clone. Lang interpret. Okay. Wrap TLS. Okay. We can run, I think this is set up to run, yeah, this is set up to do this. So let's debug it. It's bench all. You should probably use absolute paths. Okay. Edit. Parallel run. Dash dash. Use Users, Lucille. Users, Lucille. I don't know if I buy it. It's getting there. Users, Lucille. It's not also compiling the... Users, Lucille, source, bench, scripts. I swear, hitting every branch on the way down. Source, bench, scripts, bench, all with a hyphen. Every tree, every branch. Some days it just be like that, babes. I think that's, you know, like, I don't know. I'm not at my nerd. Not. I don't know. I don't know what it is. I'm not even gonna take it personal. I'm just gonna roll with it. All right. So where were we? And why were we doing this? Okay, so we're doing interpret file. We've got the slang. We come in here. We're wrapping the TLS. We go interpreter. We got alval. We got a frame stack. So now we've got opcodes, which is an opcode array, and we're getting the size. And is just like no. Obj is none. There's nothing to look at there, baby. Whose thing is this? This is opcodes. Okay. This is a garbage collection deletion bug. We are not rid of them. That's very good to know. Here's the thing. You're not doing any work, though. Wait a second. Let's see that stack again. So you're in eval now. And there you did it. Boom. But it's on the frame stack. You put it on the frame stack. Right? You go, okay, give me this thing, frame. Home context is this, and it's boom. You popped it on the frame stack. You popped it off the frame stack. You popped it off the frame stack, and the sneaky garbage collector went and said, oh, it doesn't exist anymore. I'm deleting this thing. I'm finalizing it. I'm dropping all references to it. Like, it's dead to me right here. Bottom frame. Oh, no. Well, wait a second, though. and you haven't even popped it. You're just looking at it. It's still on the top frame. Yeah, it's still, so it's still no. Okay. This is not a valid garbage collection. I assert that this is not a valid garbage collection. Okay, so I love these kinds of bugs. It sort of makes me want to turn up garbage collection even more to like 10,000. I think it's like 500 right now. No, baby, we're gonna. No, you don't need to, because you still leave anyway. All right. Okay, so. Hmm. Here's an evil thought. Cool. Neato. I didn't know that. Use that clone. Iter.enumerate take numbars. Okay. Okay. Neato. What else are you mad about? Exception. Cool. Simple table gets a default implementation. Okay. We're gonna have to rename Lang. That's gonna be a big change. But otherwise we're cool. The evil thought is, what if we just check this in and then, but no. Actually, the whole point of this, I'm rejecting it right now, because the whole point of this originally was, hey, we need a garbage collector to start collecting garbage. And now it's collecting garbage and we're mad at it, you know? And it's like, no. Now it seems like it's a little too eager. Okay. So like every time, this thing is pretty consistently failing, right? When we unlock, when we're trying to unwrap VM bench, right? So let's set a breakpoint right here. And restart it. But the other thing I'm curious about is, did we even... I want to see it do work. No. Here. Let's restart. Stop and reload. Okay. Check no borrows because we're in the debug build. Then we're going to go... We're going to step in. Self.mark. We're going to clone, step into gc.mark. Okay. Wow. Actions is 0. State is mark state. Init. We got color flip. So what is this color now? What is it? Mark self. Mark color. It's white. Epic color is black. Okay. Step over. Got the roots. Well, got the roots. Roots should now have a bunch of stuff in it. Got 4 things. Step over. If this thing is, we're going to pop it. Nope, it has a non-zero root count. Okay. Is it already marked? Nope. Whoa. Okay. So it's gray. Break. Oops. Nope, it's gray. Gray, they're all gray. Because they all just got added, I think. They all just got made. So unprocessed roots is empty. Mark state, actions. But we should have unprocessed live objects. Roots is empty. Both are empty. We just dropped all of our roots. Like, or we're uncertain. Gray roots can be roots, I think. What are you doing? What are you doing? What are you doing? Alright, that's fishy. But let's hold this out for a little bit longer. Okay. So where are we now? We're down here. There's no mark. Is there a mark queue? Okay. So they get immediately blatted from the roots. I think that is a problem. Because they will all be now starting to be deleted. Okay. I'm just going to mark stuff. So we just go through, we mark the whole thing. Okay. So why don't we continue until we are finished? Keep running. Continue running. We did not finish. Okay, where are we now? You have already deleted the fucking... Like, let's look at... what phase are we in right now? I'm curious. Yeah, this is interesting. I think you've already... You have no roots. Size is 2. Okay. And... yeah. We're back in marking. Keep running. Now where are we? Okay. How many roots do you have now? You still have 2 roots. Okay, so 2 survived the call. Okay. Well, first of all, I don't understand why we're removing marks. So we're gathering roots. Root count equals 0. Continue. Yeah, this needs to go here. Yeah. Clone. Yeah. Okay. Break. Yeah. Okay. So. Kind of wondering if that was the bug. Let's see. Nope, still bad. I think that was a bug. Is it still the same thing? Oh. No, we just hit the breakpoint. Yeah, I think you're okay now. Might have been the bug. Oh, nope, panic. Okay. We're still there. Nope, still there. You still have a bug. Alright, cool. I think there should be a function. I want a breakpoint on every after the trace. Mark, finished, scavenge, finalize, reclaim, adding root. Push back. No, you've already made it, so it should be in the mark queue and the live objects. Right? Like you're already... Okay. Yeah. Okay. Okay, so... 0. Options. No. It has a root count. Saving it. Okay. This is the color. If it's gray, it's already in the mark queue. It should already be in the mark queue. Okay. How big is the mark queue right now? 3,100. Okay. Very good. Okay, keep running. Gather the roots. Now we're just marking, I think. How many in the mark queue now? 30, 13. Okay. Why are there so many in the fuck? Have you noticed this? Mark queue is gigantic now. back to the scavenge state now. Okay. 15,314. There are 37 roots. I have a feeling that there are a great deal of redundancies in there. There are no unprocessed roots. The mark queue already has 2 things in it. Now you're going to do unprocessed live objects. I'm going to swap them, and then you're going to start scavenging. You're going to look at every single one of these. Because there are a few things in live objects that are now gray. We keep it. Are we going to have anything that's finalized? Okay. Okay. Finalize queue. 2 objects. Okay. Let's run again. Reclaim. Okay. Roots got cleaned up. Okay, good to see. Live objects. Oh, quite a bit of destruction now. Okay. Let's see. Okay. Finalize queue. 6632. Wow. and then we panicked. So we were in the middle of finalizing something that shouldn't have been finalized. No, they're not. Objects can be gray if they are new. Objects can be gray if they are new roots. Be in the mark queue. Okay. That's interesting. Oh, that's the... Yeah, okay. Mark color, you've popped it out of the mark queue. Okay. Okay. I'm not mad at that. Scavenging. So a non-root object comes in, it gets added to the live objects list, which it shouldn't need to be, and it gets added to the mark queue. No, it does, because there's no relationship between the mark queue and the live objects. We mark everything in the mark queue, but we need to know about the live objects. Yeah, so it needs to be in both of those. So everything should be in both. Or in roots, because then it gets added to roots, which is also fine to keep in live objects. So yeah, so we already have this list of live objects. They should have now been marked, but there's new stuff coming in, which can be gray. If it's gray, we mark if is SC or gray, right? So this is marking. Let's look at scavenging, because that's okay. So then we're going to swap unprocessed live objects with live objects. And then, okay, we're going to get from, if it's a match or gray, Um, we push it back. Yeah, we can just move it back to the live objects. If it's not, if it's unmarked, then we push it into obj. Yeah. Uh, yeah, that's it. If it's because if it's gray, it got added to live objects more recently than the mark phase. Like more of the mark phase took its so we just say okay, and then we go okay, we're empty. Then we're gonna finalize, and we're popping these into the finalize queue, and then from that point, we're just gonna iterate through every element of it, and put it in the reclaim queue, and then start again. Yeah, I don't know. Clear breakpoints. Continue. Hit the panic. We're in that exact same spot. No, now we're in a different spot. No, over here. Yeah. Yeah. And opcodes here is empty. It's got none. It got set to none. I know what we could do. We could set a breakpoint on the SC set code inside of raw array. Let's look at the call stack again. I kind of want to see the surrounding code. I'm starting to feel like, okay, the garbage collector is working as intended. So what happened? Input path. Let domain, refile. So this is an SC, so I feel that this is protected. Then we say, interpret this thing. Okay, so let's look inside of lane. And you're going to run the interpreter. You got a domain and SC. So domain still protected on high from the wrath of God. What happened? Interpret mod. So you came in, interpret. You have this domain. The interpreter, which is also living inside of an SC. You clone the domain, which is also protected. You add a source file. which is then a protected SC. You lex it, you parse it. You call do work. You grab the library. There's an interpreter block in it. You do work again. Domain's safe. You haven't made anything else. This is where I think your problem is that function block is unprotected. Stop. SC. Yeah, you need an SC right there. That might be the thing. All right, we're gonna push a little more on the 2 hours, but this is actually interesting work. Okay, all of these things I feel like are so when you call langgc, what do you get? What do you get? Yeah, you get an RC rest cell. So you can actually just say, you would say SC wrap in function block GC lang GC. And same thing. I think edge function def. We're just gonna keep all this shit in yeah, baby. Not safe. The frame's safe because it gets popped into the frame stack. I think we're okay. Def.edge. There. Nope. Really? Not even with your special. Where does opcodes live? So we hit, no, that's the panic. But here's the 338. Where did we get to death? That's the death. Opcodes should be tracked. Let's look at function block. No, this is function def, outer block, inner block, all of these things. That's the only thing that's not been tracked. Or the instructions, but they're not garbage collected. Okay. What about function def? It's got a VM block, right? Alright, what about VM block? Opcodes, yeah. Okay, who's got the VM block? Oh, it's in a... It is in an enumerated type, which is being told to be ignored by the garbage collector. So nothing inside a call type is going to actually survive garbage collection. Yeah. And that's the one thing that lives in there. Otherwise, it's a bunch of statics that we don't care about. Okay, so this guy gets nothing, and you get a this is terrible. You get none of that. And function def gets a VM block, which is an edge VM block. If type is interpreted, this points to the opcodes. Otherwise, it's none. Kept out of the enum to avoid issues with to ensure it continues, it survives garbage collection. Yep. VM block. Call type interpreted. New built-in, call type built-in, block is edge, new empty. No, there's nothing there now. Okay, build me. A bunch of stuff's gonna fail. equals top frame if call type equal call type if let call type built-in callable other crap equals call type. Boom. Callable. Boom. Contain. Let VM block equal top frame dot borrow block dot borrow dot VM block dot clone. There it is. What else you got? Equal call type interpreted. Interpreted. Function def. If okay. Equal block dot borrow dot VM block dot clone. Cool. And how do you like me now? I don't think you have to do that. I think you can say if function def dot borrow dot VM block is sum. If function def dot borrow dot VM block dot is sum. Boom. Okay. How do you like me now? Still panicking. In a different spot, an error formatter. Okay. Annotator. Oh. Oh, you're still doing domain.borrow.get input name instead of interpreter get input name. No? That's the correct thing to do. You still need the GC though. Oh. We gotta make get input name private. I think I might have fixed that other GC bug though. Okay, so non-stop action. I think the thing I'm going to do before I stop is that I'm going to make this, both of these functions unfortunately need to be moved over to Hadron, to length, or whatever we're going to call it. No, I know. Oh wait, didn't we have a... didn't we have a get source file which returns a source file? Okay, those are going to break, but I think this is the right approach. Okay, but let's collection crash. That was a good one. Yeah, I like that one. That was a good one. Oops. There we go. Cool. All right. All right. All right. Well, good sesh. I'm gonna go walk my dog. I'm a little worried about her mental health today, which is probably the most Gen X thing that I'm gonna say. But you know, if you took a look, thanks for coming by. If you're watching this later, drop by the live stream sometime. I generally try to schedule them with a little advance notice, so you can get some warning. You know, going back to work for medical leave next week, so I'll be my streaming schedule will probably change, but you know, I have a goal of streaming twice a week, so I'm gonna stick to that. So yeah, thanks internet, and thanks for playing along.